Hello and welcome everybody. It is quite an exciting day over here on the AWS Twitch channel. On today's stream, we'll be talking a bit more about the launch of AWS Wavelength. My name is Nick Walsh, developer advocate at Amazon Web Services, and I'll be your host for today's session. To discuss a bit more about this launch and broadly the partnership between Verizon and AWS, we've assembled an incredible panel of folks, all bringing some unique insights into what makes Wavelength so impactful. In the video, we heard a bit from senior leadership on both sides of the table, as well as customers, and we'll be extending that here with a deeper dive, followed by some live Q&A at the end. So get those questions in Twitch chat. We'll do a round of introductions in just a bit, but to kick things off, I'm going to pass the baton to George Eliseos, General Manager of AWS Wavelength, and Srini Kalapala, VP of Technology at Verizon. Gentlemen, let's set the stage a little bit for the folks that are just joining us. What is AWS Wavelength and the Verizon 5G Edge?
Thanks, Nick, and everyone watching. We're all very visibly excited to be here in the position to announce the general availability of AWS Wavelength today, both the AWS team, but also our Verizon friends. To your question, put simply, AWS Wavelength brings AWS services to the edge of the 5G network. In this way, it enables developers to build applications that reach end users and devices with ultra-low latencies. Wavelength is really made up of wavelength zones. These are infrastructure deployments that embed AWS compute, storage, and other higher-level services into the 5G edge, physically close to the end devices. And today, we're announcing the general availability of two of these zones in the Verizon 5G edge. One to give low latency to the Boston area, and one to give low latency to the Bay Area. AWS developers will use these wavelength zones to deploy the latency-sensitive parts of their applications, while also seamlessly accessing the full breadth of the AWS services back in the AWS region. But the cloud is just one of the ingredients here. The other key is the technology of 5G. And maybe for that, I think I'm going to go over and pass to Srini, who can say a lot more.
Thanks, Nick and George. It's indeed a very exciting day to announce the general availability of the Verizon 5G Edge with Wavelength. Hello to everyone who's watching the stream. I'm going to give a little bit of background related to 5G. From the day we start talking about 5G, we've been saying that the 5G that Verizon is building is not like any other 5G or that's incremental to 4G. We've been building a transformational 5G network. So in that aspect, we talked about millimeter wave spectrum, we talked about slices, we talked about the 8 different currencies, and we also talked about multi-access edge computing. And our goal always has been to bring the best out of these technologies and allow for a transformational network to emerge out of this, right? So let's talk about what we've been doing in kind of bringing these out. In February, we announced that we were able to deliver 4.2 gigabits worth of bandwidth to a smartphone. That's very exciting if you look at 4.2 gigabits. Now, what's happening there? We actually have more coming down, and we keep pushing the technology. Same way, recently we announced that we've successfully tested and trialed a SA packet core. It's called standalone packet core. Now, that's what is going to enable slicing, and we talked about slicing, and that's again in the works, and it's going to come out. We also talked about that. That our goal is to bring in the best of the network and the best of the technologies together to deliver this transformational experience. And in that aspect, we started working with AWS about 2 years ago. We started working together on the 5G Edge. We, in fact, did a trial 2 years ago on the 5G network. Then last year at reInvent, we announced the preview of the Wavelength 5G Edge. And now we're here bringing the 5G Edge general availability to all of you so that the enterprises and the global developers can start leveraging these technologies and develop the future.
Yeah, so I mean, the bandwidth possibilities with 5G are clearly immense, as you mentioned. You touched a little bit on the partnership and sort of how this has come to be this long multi-year process of experimentation and ultimately rolling this out. George, on the AWS side, what did it look like to bring a partnership with Verizon for something like Wavelength to market? What did this take?
Yeah, as Srini said, our collaboration has been on the works for quite some time, and we pre-announced the Wavelength Zone at the Verizon 5G Edge in Chicago with Andy and Hans on stage. And that was a really exciting announcement, but it was also a pretty big shift from the traditional approaches of mobile edge computing. And this is where the two teams really came together. Traditional approaches really focus primarily on network, to not necessarily do enough to bring the developer ecosystem into play. With Wavelength in the Verizon 5G, we're breaking ground by bringing both of these equally important parts, the cloud and the 5G network. We're starting with 2 zones today, one on each coast, but this is just the beginning. We've been working with Verizon, and we have grand plans on a series of additional zones coming up over the next few months all across the US. Our shared goal is to make Wavelength ubiquitous and truly bring the offering close to as many 5G devices as possible. And we also want to bring additional network and compute functionality and features to our customers. So overall, really excited with where we're going and to see what customers will really do with these new capabilities. I have to say, we're all at AWS really stoked to be working with Srini and his team. Just 8 months ago, we were at re:Invent pre-announcing together, and now we're here talking about the launch. It's just the beginning, and we're really looking forward to continue this inspiring collaboration.
Yeah, well said, George. I would say it's been an incredible partnership. I think both the teams are, working together. We're innovating and we're accelerating some of these technologies. When you look at it from our customer perspective, we're not only bringing the best of the network to them, but also bringing the cloud, the best of the cloud, closer to our customers. Now, as you see how the tech is evolving, it's not simply going to be the network. It's also going to be the cloud and the application and others. And whoever can actually bring them together, make it very seamless for developers to access, are the ones who are going to drive the acceleration of these technologies. So since re:Invent, we've been working together to harden the technologies, work on the process to scale it, nationwide. And Josh talked about the potential, the announcements that will be coming down the road. And then we actually onboarded a few partners onto this platform to ensure that the vision that we're driving towards is what the experience they're actually getting. So when we look at the partners, I know the video that you saw kind of showcased a couple of them. Partners didn't have to do anything different than what they've been doing on the AWS to access the Wavelength, the platform, and the 5G network. And as they onboarded, they actually are really seeing the benefits of the bandwidth and the latency and others. So certainly, all of those learnings have kind of helped us to not only get to the launch today, but scale as we go forward. Look, the way we see this is it's now you, the users, the developers, who have to show us where we're going to take this to. We'll bring all the capabilities and the foundational techs that you need, but you are the one who are going to build the future, and we're here to kind of assist you on that.
Wonderful. George, Srini, thank you so much for that introduction. Did a really good job phrasing sort of the high-level overview of what a partnership like this looked like and how it came to be. Now, I think one of the key themes of today's broadcast is going to be partnership. And so in the launch of AWS Wavelength, there are many other folks that were involved in making this possible, many of which are in the room with us today. So before we go into some questions that I have for each of them, I'm going to ask us to go around the horn here and have everyone else introduce themselves.
Hello, thank you, Nick. Chris Barclay, Product Manager for Wavelength.
Hello, everyone. Saravan Shanmugam here. I'm a Wavelength Solutions Architect.
Hi, Terry Sender, and I'm the lead for Edge Compute and Managed Solution Products at Verizon.
Yes, hello, I'm Kirk Campbell. I work for Verizon and I lead the MEC architecture team.
Wonderful. Well, everyone, thank you for joining me on the call today. I've got some burning questions for each of you. We'll dive a little deeper on each of your roles and some of the specifics around each of your expertise when it comes to Wavelength. But kicking things off with Chris. Chris, we've spoken a little bit about Wavelength, but something that I'm wondering personally, why did we build it? I can imagine ways this is valuable, but here at AWS, we talk a lot about customer feedback. Can you talk a little bit more about the motivation behind this product?
Sure, absolutely. So as George and Srini said, we saw an opportunity to basically combine the benefits that developers have come to love about the AWS cloud, including a broad set of services and pay-as-you-go pricing and elasticity, with the ultra-low latency and high bandwidth that Verizon's bringing to market with 5G networks, and thereby enable developers to create truly novel experiences. And you heard just a couple in the previous video, everything from applications for game streaming and industrial automation, autonomous vehicles. These sorts of use cases require, not only more compute and data processing, but they want that compute and data processing closer to the device. And so Wavelength allows us to address those challenges by bringing those AWS services right to the edge of the 5G network, minimizing the latency to connect an application from the mobile device.
Wonderful. Yeah. Excited about those specific use cases that you brought up as well. But, as someone who's followed reInvent and some of the recent launches that are networking related from AWS, like our recent reInvent, there seem to be a number of new services in sort of this broad category. So I'm wondering, how does Wavelength fit into the broad spectrum here of these newer offerings, like outposts or local zones?
Sure. Wavelength Outposts and local zones all bring AWS services to more places with the same services and tools developers are used to. But Wavelength is unique in that it's designed to enable developers to build ultra-low latency applications for mobile devices by extending AWS infrastructure, services, and APIs and tools into those 5G networks. And so developers can take existing applications, as Srini said, extend them right into Wavelength zones, or build even net new applications with AWS services like EC2 and EKS.
Yeah, Chris, last question for you for just a moment. I'm sort of wondering, the desire to bring compute closer to the edge where customers are is a total no-brainer for me. But I'm wondering, previous to Wavelength, how are enterprise customers currently addressing low latency requirements, and what are the challenges that they face in trying?
Sure, yeah. So some of our enterprise customers today use on-premises hardware to address their low latency requirements, but that requires capital expenditures and operational expenditures and isn't really very elastic. Therefore, we see organizations steadily shifting their workloads to the cloud. But the cloud, it really isn't close enough for certain use cases, like IoT devices or robots with video cameras that are generating vast quantities of data that need to be analyzed in real time. And so now with Wavelength, they have a choice to use 5G and AWS compute to get all those benefits.
Wonderful. Yeah, looping Kirk in over there, I'm wondering, why do you think that integrating cloud into 5G networks is a game changer? I know we've heard a little bit from the AWS side, but figured I'd give you a place to chime in here.
Yeah, thank you. Simply put, bringing the two technologies together is going to benefit customers and drive innovation. Verizon customers will get the benefit from access to the AWS's broad array of compute, storage, analytics, machine learning services. And then AWS customers will be able to benefit from Verizon's advanced network technologies, our density, massive capacity, and strategic placement of our network. And then bringing these two things together provides a basis for us to, or for customers to innovate and create new use cases around machine learning, fully immersive virtual reality, augmented reality. Really, it's just the beginning. We're just interested to see what everyone's going to make.
Yeah, I mean, I think it really comes together for me, again, low latency by being at the edge, higher bandwidth, these common APIs that developers like from the cloud at AWS, pay-as-you-go pricing. Chris, coming back to some of the things that you spoke about before, you talked to some of those use cases for how folks are going to make the most out of Wavelength. What are those areas, if we could dive a little bit deeper, and what are you think that are use cases that people will be most interested in here?
Sure. So we mentioned, or we had 3 customers in the launch video. A couple others that I think are pretty interesting that are mentioned in our launch announcement is one, the emergence of vehicle-to-everything communication technology increases vehicle safety by sharing information between motor vehicles and transportation infrastructure. And every millisecond counts for unexpected driving situations where there might be blind spots or potential collisions. You want to avoid those. And so by using Wavelength to host parts of the connected vehicle infrastructure, you can lower latency for that information and support the vehicle density in those major metropolitan areas. So that's one kind of that we're pretty excited about. Another one is being able to do video encoding distribution for live events. You can see that like today, certainly video encoding distribution is something that people have done for a long time. time. But one of the things we hear from customers is that they want to have ultra high definition video streams that need both low latency and bandwidth to keep up with the live event. And they want to embed interactive experiences into those streams to enhance the experience for the end users. And so I think we're seeing the potential for new generations of live events that might come online with the emergence of Wavelength and 5G. I think, Terry, you might have a couple others to mention.
Yeah, no, Chris, those are great examples, right? And when we take that in the context also of, I mean, the other items that were brought up on the call so far, but also what Tammy and Matt mentioned earlier, you kind of see very much, as we've been talking about, that transformative nature associated with what happens when you put wavelength at the edge of the Verizon network. And then when you think about that in the context of mission critical applications, particularly in the manufacturing space, I think we can highlight a few here that really kind of bring that home. So first off, when we think about like computer vision, we talked about computer vision as applied to quality assurance for precision parts being applied, and that was covered earlier in the video. But that same capability, and we have customers working with us today on taking that same concept, applying it to packaging inside of a logistics environment, or then transferring that into a food processing and food production facility, also for quality assurance. And then you can take similar capabilities in a different aspect of the factory and take a look at how AGV controls, autonomous guided vehicles, can be complemented with sensorization and camera capabilities to now all of a sudden enhance employee safety inside of those environments. And then I think I would take probably one more, which kind of, even though it applies very well to the manufacturing space, actually crosses many different industries. And this is the whole concept around inventory management in real time. And we take that concept, tying together very similar concepts of sensorization, analytics at the edge, computer vision, and you start to apply that to looking at material and components and production product inventory. All of a sudden, you can really impact a business from completely from production all the way through to consumption.
Yeah, and to add something to this, and maybe just echo what others said here, what we all have found very exciting over the past few months when talking to customers about the potential applications in their business is those light bulbs that come up as you're talking to customers and bring the value proposition of what we're getting at with Wavelength. And you can see how they start thinking about how their business can be transformed with this new capability. So just to echo that, we are all really excited to see what customers will do with this. We see that as we talk to more and more customers, more and more ideas come up. We really believe that 90% of the applications that will run on this have not been written yet.
Awesome. Yeah, I mean, when we hear about these use cases, I work with a lot of customers on the AWS side here. Sort of all the gears start clicking for me as to who would be most excited about this. But I'm curious, on the Verizon business side, Harry, maybe you could take this one. Why should Verizon business customers be very excited about this launch?
Yeah, no, absolutely. I mean, for many of the points we just highlighted, for instance, the transformative nature of what we're doing with regard to wavelength and 5G at the edge of the network really starts to address specifically the challenges that businesses have today. I mean, if we take a look at the current environment, the change in the demand zone transformation are really driving a great deal of this discussion with us. A lot of the use cases we've talked about are only intensified based on that those activities. So let's take, for instance, the fact that once we deploy wavelength along with the 5G network in an environment, we are essentially giving a business the ability to run their operations and serve their customers with across that entire market in real time. But of course, one of these aspects is that we've made it very easy, along with our AWS partners, to really onboard devices and applications into this space. I mean, it's very simple, very intuitive. However, we know that there are customers on the journey, right? They're adapting, they're evolving. So we bring our SI and partner ecosystem also to the table collectively to help them not just evolve and adapt, but also create disruptive solutions to really go after their market. So truly a transformative, set of technology.
Yeah, If I can add one more thought to, sorry, Nick, I was going to jump in and add a thought here. Look, you've heard us use the word fourth industrial revolution. Look at it, if you've seen what happened in the past few years and few decades, the digitization has come to consumer applications and it entered enterprises in terms of taking on backup and others. But there's still lots of industries and factories out there that are yet to be digitized, robotized. And what that requires is not a normal network that you have today, but a network that is highly reliable, highly predictive, and that can deliver kind of bandwidths and throughputs. But just simply not that is going to generate so much data. You need processing at the edge, you need intelligence at the edge. And what we are putting together here are basic components of driving that revolution, right? So going back to George's point, we putting the basic ingredients at the hands of the developers and enterprises. Now we're going to look for them to really start leverage them and then deliver the experiences.
Yeah, to sort of just bounce off of that point, the increasing amount of data from sensors, the desire to have this low latency performance from applications, one of the most applicable arenas here, I'd imagine, machine learning inference at edge. Chris, going to punt this one to you, but what makes inference at edge possible with Wavelength? Obviously, round trip or latency is a little bit lower, but it's a little bit more than that.
Absolutely. We're really excited about the possibilities for inference at edge. And there's many use cases for it. You saw just in the video preceding this, the smart factory example mentioned by Tata and the healthcare example mentioned by Avisha. But generally, one challenge with machine learning applications is the responsiveness. Previously, you had to deploy your inference processing application really close to the end user, especially if you're using video. And that meant the device needed expensive and power-hungry processors. And additionally, if you wanted to update your machine learning model, you had to push out an update to the devices that were running your application. And now with 5G and Wavelength providing significantly lower latency and much more bandwidth compared to previous generation mobile networks, you can use the cloud as an extension of your mobile device. And so for edge applications, this implies you can actually perform the inference processing even with HD video in a wavelength zone with that real-time responsiveness back to the mobile device. So by moving the inference processing into the wavelength zone, you're reducing the power requirements and battery drain on that device. But additionally, you can just simplify your whole application lifecycle. Like when you need to change your training model, you simply just update the servers in wavelength as opposed to having to make changes to those mobile devices.
Yeah, a lot of challenges with running ML inference on edge devices. So bringing these closer to folks in wavelength zones is immensely helpful. So I'm wondering, when I'm thinking about porting my applications and delivering them through wavelength zones, I'm wondering what services are available. Generally available in both the San Francisco and Boston wavelength zones today. So what services can I expect to be available if I open my console?
Sure. So you can run the low latency parts of your application in wavelength, and you run them on services like Amazon EC2 and EBS. We have a good assortment of EC2 instances for general purpose processing as well as processing with GPUs available in wavelength zones today. And you can also use the services that orchestrate EC2 and EBS, like the container services with ECS and EKS, EC2 autoscaling. Those are all available for you to use today, along with other services like CloudFormation and CloudWatch and so on. Of course, the resources in Wavelength are connected to your VPC that runs in the region over a highly reliable and high bandwidth connection, so you can have access to all the services that are running back in the region for the rest of your application needs.
Wonderful. Yeah, I mean, those services are quite literally the building blocks of many applications. And I think that's a good segue into bringing Sravanan into the fold here. Sravanan, as a solutions architect for Wavelength, you help customers build applications using these fundamental building blocks. And now Wavelength, can you tell us how do services running in Wavelength zones connect to the 5G network and back to AWS regions? Because I think this is something that most people are probably wondering if they're interested in using this today.
Thank you, Chris. Yeah, absolutely. That's a great question. So let me walk through the flow, right? So when a customer selects a region where Wavelength Zone is available, they create a VPC, then they create subnets in the Wavelength Zone. Once they create a subnet in the Wavelength Zone, they can run EC2 instances, ECS container instances, or EKS worker nodes in that subnet. and run their applications on top of it. These applications running on Wavelength Zone can then access all the resources in the region using that secure and high bandwidth connection that we have between the Wavelength Zone and the region. With AWS Wavelength, we are also introducing Carrier Gateway, wherein customers create a Carrier Gateway, attach that to the VPC. The main functionality of Carrier Gateway is to provide connectivity between the Wavelength Zone and the carrier network, which then enables your application to reach all the devices in the carrier network. The Carrier Gateway also performs NAT for the Wavelength instance private IP addresses, carrier IP addresses, which is located from a pool of IP address which belongs to the network border group. The Carrier Gateway's NAT function is very similar to how an Internet Gateway functions in the AWS region. So these are the steps that customers use to connect back to the region as well as connect to the devices in the carrier network.
Yeah, so diving a little bit in deeper, if I'm thinking about building applications using Wavelength zones, what are the considerations that I should have or developers at home should have when thinking about architecting applications to make the most of Wavelength zones? Now, I'm thinking most like AWS well-architected or best-architected principles, concepts around the realm of security, reliability, making sure I'm getting the most of high bandwidth connectivity back to the AWS region. Can you walk us through how someone would achieve all of those things?
Absolutely, absolutely. As you have heard Chris and Srini and others talk about how critical it is to place the application which requires low latency at the edge of the network where Wavelength comes in. So Wavelength Zone is specifically designed for application which needs to connect to compute from mobile devices with ultra low latency and the application which needs high and consistent data rates from mobile devices. So AWS recommends customers to architect their edge application in a hub and spoke model with the region to provide you the most scalable, resilient, and cost-effective options for components that are less latency sensitive, application that needs to persist data, such as databases, when you want to train your ML models, some of the control plane applications, and place the other part of your application stack, which requires that low latency sensitive path of the network close to the Wavelength Zone. So by that way, you're taking care of all the benefits of the resources and then place a critical part of your application edge powered by Wavelength.
Yeah, thank you. I think that gives me a much more sort of tangible idea of what it looks like to build and use Wavelength zones. Kirk, I've got a question for you now. So if I'm not mistaken, in that opening video, we saw, again, not just from executives and folks on both sides of the table here, but also customers and users of Wavelength zones. And one of those was Avacia with their shot tracker module. I know that they've seen quite a few benefits moving to from 4G to 5G and using Wavelength. Maybe you could talk a little bit about what that experience has been like for them.
Yeah, actually, yeah, you could actually see it in the videos, right? And seeing is believing. Like the key is improved latency, which is really a major tenet of the service offering. In the Avacia video, Raj said that if the green bounding boxes weren't moving, identifying and moving quickly enough, then they wouldn't have highlighted the polyp, which was a really small polyp, and that would be the difference potentially between the doctor and missing it, seeing it, which then the doctor being able to see it allowed for easy early identification of a potential cancer, right? And as we all know, the earlier you identify something like that and you could deal with it, the much higher chance of a survival rate. And in the case of the shot tracker video, the demo that they provided showed two people passing the basketball back and forth, and it was easy to see in the video display. But also another key thing is you could actually hear it from the in-room microphones. That the 4G network had a considerable lag, but the 5G network moved the ball along in real time. And these are important key capabilities as shot tracker adds more functionalities and new customer use cases. So the latency improvements were pretty obvious.
Yeah, and I know at first glance, folks thinking that reducing latency is maybe an incremental improvement on workloads they already have, but I think sort of like the truly real-time applications like passing a basketball, for example, it just enables another class of applications that previously were not technically feasible. So much more than just sort of this incremental improvement. Sravanan, another question for you. So you were very involved in this project and having to think about how users would architect with it. Could you give us an idea of maybe what a typical reference architecture would look like here?
Sure, yeah, absolutely. If you have seen the announcement, if I take Avisha's use case as an example, Avisha's team is using the power of 5G and AWS Wavelength to bring deep learning to the edge to solve a healthcare problem. When we started working with Avisha to architect a use case to run on AWS Wavelength, we clearly saw the need for a robust platform like Amazon SageMaker to train and tune their models in the AWS region and then deploy the trained model to run on Wavelength for real-time inference. A typical architecture, if I could look at and think about it, would be like to use Amazon's SageMaker operator for Kubernetes to power the entire platform, where we can leverage node groups in the region to train and tune the models that the team is developing, and then seamlessly deploy these models in another set of node groups running on Wavelength Zone, which then provides that low latency inference to the application at edge. By leveraging the SageMaker operators for Kubernetes, customers can specifically focus on enhancing their models instead of worrying about the deployment artifacts and managing the machine learning pipeline. Right? I think Thierry's team also worked on it with us on this project. I would also let Thierry, if you want to add a couple more points to that.
Yeah, no, I think they're all really great points, highlighting the value proposition of running AI at the edge for workloads that go, quite frankly, beyond what we did with Avisha, but that is really highlighted and exemplified by what we did there. And in part, it also shows how the two elements really come together and work well, which is 5G and the wavelength capabilities with analytics running on them. Because that combination where we're able to use the performance characteristics of 5G to provide that low latency capability, where the capture, the presentation, the analysis, all can be done in real time back to the doctors during the course of the activities, but also the flexibility, because the fact that you can run all this on the video capture and everything over a 5G network deployed into these various doctor environments really shows kind of, again, the transformative nature of how when you take those elements of 5G and combine them with wavelength, you can all of a sudden support these use cases that, quite frankly, as Nick said a moment ago, were not just possible any other way. Yeah.
Absolutely.
Yeah, so you've convinced me. I'm about to go and use wavelength zones, but I have an important first question, and that's, if I'm thinking about getting and delivering my applications closer to end users, I have to think about where I want to deploy them. So maybe I have users in parts of California, and I'm deciding between maybe US West 2 and the newer San Francisco wavelength zone. So Sravanan, maybe you could answer this one. If I have a client application, I want to access the lowest latency possible, how do I know if a particular region or wavelength zone will deliver better latency? And is there an easy way to figure this out?
Thank you, Nick. That's a great question. When customers create an application or services today, and they run these applications on EC2 instances or ECS container instances or even EKS, what they can use is they can use AWS Cloud Map to register their services and applications. When applications running on the client devices can then use API calls to the AWS Cloud Map service to discover these endpoints already, right? So when you deploy applications across Wavelength Zone, use these API calls to the Cloud Map service for your endpoints, and then run latency services or latency test across these endpoints, even as ping, right? As simple as ping from these client devices to select the best endpoints that you have discovered from the cloud map. Or even use your geolocation data from the mobile device itself to differentiate between these endpoints to see what location you are and how to differentiate between endpoints as you discover them from AWS Cloud Map.
Awesome. So yeah, if you're a developer, being able to, sort of ping the zones respectively, or the AWS region, I think it becomes quite clear quite quickly, which will deliver better latency for your end users. So, okay, yeah, we're sort of nearing the end of a lot of the topics that we want to talk about. We've got one or two left in the pipeline, but a friendly reminder, again, this is live, and we're going to be doing some QA in the end. So get those questions in Twitch chat. I mentioned before I had one question to be answered before I got started with Wavelength, but I lied. Sorry, I have one more question. Chris, you're probably the best one to answer this one. I'm a developer. I'm interested in getting started. How can I do that today?
Yes, awesome. So I sure hope there's a lot of folks on the Twitch feed that are feeling that way. You can go. I think, Nick, are you going to post some links into the chat? We have our own marketing page, and there's a sign up form there. So please just go to the sign up form and enter your details, and we'll get back with you. And then we have two events that are coming up, one in San Francisco area and one in the Boston area, that'll let you basically get quote unquote hands-on with Wavelength. And I think these are going to be really exciting. So please feel free to sign up for those events as well.
Wonderful. Well, looking along in chat, we'll be collecting those questions in just a second. But first, I have a few of my own, just because I'm the host here. I'm selfish. Let's get these questions answered. So, Chris, you're in the hot seat. You just answered that last one, so I'll keep you in there for just a moment longer. I'm wondering if customers have feedback around, let's say, services they would like to see available in Wavelength Zones, or an idea for the hottest new Wavelength Zone location. How can they provide that feedback to us?
Sure. So, I mean, both companies love hearing from customers, and we really want to get input. We feel this is just day one for Wavelength, and we know there's a lot that you're probably going to tell us about as you start using it. And so, lots of ways to give us that input. Maybe the simplest is, all of us are on Twitter all the time. So feel free to send us a DM or post something about what you're interested in seeing. We'd love to hear from you. And of course, there's other channels as well. If you're working with sales from either of the companies, you can always use that channel as well. And then, of course, there's other places like AWS forums and Stack Overflow and so on. So we monitor all those, and we are eager to get your feedback.
Awesome. Yeah, I shamelessly plugged my Twitter handle in there, but if you reach out and message me, I will get those messages and that feedback forwarded along to Chris and anyone else who that would be relevant for. Cool. So we've got one question from chat. This question is, does Wavelength only work with 5G devices? Totally valid question, and the desire to bring, low latency sort of to the edge is totally valid, regardless of whether the bandwidth increases there. So I'm not sure if anyone in particular wants to jump in here, but question again, does Wavelength?
I can take that. Thanks, Nick, and thanks for the questions. As Chris said, we love this. The answer is no. Wavelength works also with LTE for 4G devices. The reason that we're mostly talking about 5G is that is where the full potential of the technology that we're building materializes. Obviously, some of the 5G advantages was brought up by Srini and by Terry and Kirk, but also it's the future as well. It's what's available today, but also what will be available in 5G. We have obviously the bandwidth and number of devices, the density that 5G will support, but we also have the network functionality and other new functionalities that like slicing and other really forward-looking functionality that we want to bring to our developers. So that's why we're focusing on 5G, but you could go out and try Wavelength today on 4G devices. I don't know if anyone else has anything to add.
No, it's a great point, George. And I'll just add that, for instance, because we're able to support 4G, that means all of the development kits and capabilities that we've done, and many of which we've done together jointly with AWS in the past, for things around the IoT space, for instance, have come along in this journey in terms of being able to get the benefits and value proposition for Wavelength. But we're also moving aggressively to provide next generation 4G dev kits, and also we now have a 5G dev kit that's coming onto market. So now, in terms of building your solutions end to end from device all the way through application, you have a complete suite of capabilities to do that.
Wonderful. You know, I was going to ask a little bit about to the Verizon folks what sort of network integrations and experiences users could expect, but I feel like on the piggybacking off of the 5G topic, you happen to mention a few of those. Any other insight though on that in that space?
Yeah, just that it'll be a seamless experience, right? And once you pop on your carrier address, you're off to the races.
Hey, less is more in some instances, right? User experience, the more you can get out of the way of developers, the better it is. So I'll take that one. One more question for anyone at AWS who's interested in taking this one. You know, we think about these Wavelength 5G edge sites and Wavelength zones as you know, different regions or areas that we can deploy applications to. Is there a special onboarding process to be able to use this? Do I have to significantly change my applications? What does it look like to actually get onboarded to one of these 5G edge sites?
Yeah, I can take that. I mean, essentially, what you need is to go to that landing page that Nick posted into the Twitch chat and ask for access, and then we'll get back to you with the access, and then you just go to the AWS console or CLI or SDK, just like you always have for your own application. Create a subnet in a new or existing VPC with the Wavelength Zone that you choose, and you can start creating EC2 instances and deploying your application there. Of course, you'll need a device on Verizon's network as well to actually connect to those, as Saranavan mentioned, but it's really as simple as that. It's just another place to deploy your application in existing AWS infrastructure.
Yeah, some of the most exciting feedback that I believe we've gotten this far, and Chris, you probably can bring up specific examples, is I managed to extend my application within 24 hours to take advantage of, you know, our Chicago pilot zone. That's feedback that we've gotten over the year, which is exactly what we're aiming for. We don't want necessarily developers to have to do a lot of work to leverage Wavelength. That's why we're using the same tools, the same services, the same EC2 hardware types, the same VPC abstractions in Wavelength in order to enable developers to just go.
Yeah, I can also jump in there. You know, working with tens of different pilot customers, they were surprised to see that there is no change in which they are accessing these wavelength zones. The APIs, the console, it's pretty much deploying a subnet and getting access to a wavelength zone, and then deploying their applications and use the edge, the power of 5G and edge, and also the power of all the services in the region pretty seamlessly. As George mentioned, not even 24 hours, just they get access onboarded, they're pretty much on their way to get started and deploying their application and get started. So it's pretty seamless from a developer experience standpoint.
The way that we like to think about it when we're designing the various features of Wavelength and how we're enabling it is, this is not like AWS, it is AWS, right? So that's the kind of like a principle for us.
Wonderful, yeah. Happy to get all the perspectives on that one. So I think I have time for about one more audience question. Before I get into the final question, though, for folks that are looking to get started with Wavelength, I believe there are some upcoming events that folks can actually get hands-on with Wavelength and in sort of an instructor-led fashion, be able to get onboarded to it and be familiarized with it. I think we have some links to those. We'll throw those in chat. So if you're in either of those locations, may be of interest to you. But sort of closing out in today's segment, final question from the audience. We hear a lot about slicing. It's something I'm not personally that familiar with, but folks are wondering, when is that coming and how will that enhance?
I'll jump in. Slicing is coming in months, and how that enhances is, imagine that today you are used to getting three kinds of services. You got a broadband service, which is the data service. You have voice and messaging. Imagine that tomorrow that you're driving in a car, you want the car to have the ultra reliable connectivity. You don't want any kind of packets getting lost or something else, right? You want the car to always drive on its own, but at the same time you are having entertainment, watching movies or calling somebody else. So creating these different layers of slices to suit the different use cases is what the 5G network is going to enable. And these slices are end-to-end, they're created independently, which means that the higher reliability, higher performance services will come with that level of guarantee. And the BAU services, the services that you're used to, the normal basic service that you're used to, they'll continue to be available in the way that you can consume. Just to kind of throw it out there, the 3GPP, the standards body for the wireless technologies, they envision about 128 slices to emerge. And right now there are a few like URLLC, ultra reliable low latency communication, MMTC, and a few others are getting defined. We expect more of these to emerge as we go forward.
Wonderful. Well, I think without further ado, that is going to conclude today's session. I know an hour flew by. We opened up with that 15-minute video from folks on both sides of the table at AWS and Verizon talking about this partnership, and we actually got to actually see it in the hands of some customers and what they're building with it, which was quite exciting. And a big thank you to everyone that was here on the panel here: Saravanan, Terry, Chris, Srini, George, and Kirk. Myself, Nick, give myself a little pat on the back there. But again, thank you for tuning in. Thank you to everyone who is in chat who submitted live questions. We appreciate those, and we hope we were able to get those answered for you. Again, if you're interested in learning about Wavelength, we have some of those learning links. We'll throw the links in chat. If you're interested in getting, we have a link there for the getting started documentation as well. So again, very excited today, very exciting day, the launch of AWS Wavelength with 2 zones in both Boston and San Francisco. So again, thank you everyone for tuning in. That is going to do it for us. Have a great rest of your day, and we will see you all soon. Thanks everyone.
Thanks everyone.
Thanks.
Right. Thanks.